write all of this. And this is how we're going to write it on or notate it on our square. So both pairs of opposite sides are parallel. So this side is parallel to this side, and this side is parallel to this side. Notice how I did the two little arrows on the top and bottom side, because if you just put one arrow on all of them, it would mean that they're all parallel. They're not. So opposite sides are parallel. The next thing we know about a square, and this is hopefully an easy one, all sides are congruent. Remember, congruent is just a fancy way of saying equal. So we would just say, okay, this side is congruent to that side, which is congruent to that side, which is congruent to that side. The next thing we know about squares, both pairs of opposite sides are congruent. Okay, so this side is congruent to that side, and this side is congruent to that side. And we know that because all sides are congruent, right? But technically we do need to know that. The next thing we know is that diagonals bisect each other. All that means, y'all, is look, this side over here bisects this side over here. That's all that means. Okay? You can even put like more of it than just like dotted. Okay? The next thing that we know about squares are that diagonals are congruent. Again, that's the thing that the diagonals are equal. So this diagonal here, so this one, is congruent to that diagonal there. Okay? So if I take a square and I say, okay, meet me on the other side, and then someone does the exact same thing, it's the exact same path, essentially. The next thing that we know about squares, are that diagonals bisect each other at right angles. That one is easy to remember because it's a square within a square. So remember, they could also word it as perpendicular bisectors. So if they said perpendicular bisectors, go ahead and put that in parentheses. That just means that within here, all of these are right angles. So I'm going to say a square within a square. That means that the diagonals bisect each other at right angles. The next thing is that both pairs of opposite angles are congruent. I'm going to go ahead and write the next thing that goes with that, because I hope that we all know about squares, all right angles. So these are all right angles. So you should have your boxes. And so of course both pairs of opposite angles are congruent, because this one is congruent to that one, and this one is congruent to that one. They're all 90 degrees. The good news is, y'all, that's the most difficult one. So it all goes downhill from there. So let's talk about rectangles now. Alright, rectangles. are congruent. So this side is congruent to that one, and this side is congruent to that one, right? So opposite sides are congruent. We also know that diagonals bisect each other. So look, bisect just means they intersect together. Okay? They are also congruent. So the crisscrosses in the middle are congruent. So we're going to put 3 dashes on them because I've already used 1 and 2 dashes on the outside. Let's go to pink. For a rectangle, diagonals bisect each other at, no, that's not true. Sorry. We're going to go to the angles. So once again, both pairs of opposite angles are congruent. And like I said before, all 4 right angles. So the way that we talk about that, easy. Just put your boxes. And of course, opposite angles are congruent because that one's congruent to that one, and that one's congruent to that one. Next, we got the rhombus. So y'all, all of rhombuses is a funky square. Taking a square and then we just go eat to the sides. Okay? So a rhombus both pairs of opposite sides are parallel. So this side is parallel to that one. This one's parallel to that one. All sides are congruent. Remember, a square, all sides are congruent. So a rhombus is just a funky square. So all the sides are still congruent. Both pairs of opposite sides are congruent. That makes sense, right? If they're all 4 congruent, then obviously the opposite sides are going to be congruent. The diagonals bisect each other. The diagonals are perpendicular, so perpendicular bisectors. So they all, remember, it's a square within a square, so a rhombus is just a funky square. And then last but not least, both pairs of opposite angles are congruent. Now these are not right angles, right? But this angle is congruent to that one, and this one is congruent to that one. 2 more. Parallelogram. Parallelogram is just a funky square. Oops, not funky square. Funky rectangle. Okay, so just like everyone before, both pairs of opposite sides side, or that angle is congruent to that angle, and this angle is congruent to that angle. And last but not least, everybody's favorite. This is why the trapezoid is everybody's favorite. Because it's got one thing and one thing you gotta know, and it's this. Exactly one pair of opposite sides are parallel. And for this one, it would be this side is parallel to that side. This other side would not, because look, eventually they're going to intersect, so they are not parallel. That's the only thing you gotta know about a trapezoid. So make sure you have this all written down, hopefully coordinated, color coordinated, so that when you do your practice problems and when we do practice in class, you're ready to go.